So it's really great to see all these people here for a quantum event. It's great to see a quantum event in the Navy Yard, so I think this is all exciting times. So we were actually one of the first US investments that Quantum Nation did in 2019. We are a spinout of Stony Brook University out in Long Island. And as Will mentioned, we have a lab which is 2 floors down, which is giving tours tonight. We also have a second facility on the other side of the Navy Yard, so if anybody's ever been over to Russ and Daughters or to the brewery, Transmitter Brewery on that side of the Navy Yard, the same building houses actually our fiber facility for doing all of the networking that I'm about to describe. So what we do is we pioneer solutions for quantum networking, and quantum networking is literally a new way of thinking about how you use single particles of light to transmit information which is physically encoded onto those particles themselves. We spent the last few years working on a very seemingly simple but difficult problem. And that problem is essentially, how do you transmit these photons through regular fiber across a vast network and actually preserve the quantum quality, which we'll call fidelity? And the reason that's hard is because these particles of light, they're very delicate. I think some of you have probably heard the term entanglement. So what we do is we distribute entanglement across regular telecom fibers, but because it's so fragile, we have to figure out ways to be able to preserve it and to do it with high quality. Why do we bother? Well, at the end of the fibers, you can connect things. So just like our standard internet, you'd like to connect quantum computers, or you'd like to connect quantum sensors, or you'd like to send secure information between 2 nodes. So that's what we've been working on for the past few years. The problems we're specifically working on, the variants of those, are that first, we're trying to figure out how can quantum today help what digital is doing? So are we going to rip out our entire infrastructure in order to actually replace it with quantum infrastructure? No, not really. What we're going to do is we're going to build upon what we already have. So what Qunnect is doing is that we are actually figuring out ways that quantum can enhance existing digital networking. Yes, thank you. So you can think of it like, how do I mix quantum and digital in order to actually be able to provide enhanced security, or could we use it in ways that to do things like position verification, where right now spoofing is up at alarming rates, basically. And what we can do is use the quantum itself. The entanglement is a sort of way to test whether we have something secure transmitted between the 2 buildings. And then the other thing we do is we think a lot about, we have quantum computers which are evolving today at rapid pace. You're seeing it all the time across the different news media. How are you going to connect those things? We know that in the 60s, right, the first technologies were available to connect digital computers. In the 70s, there were like 4 or 5 nodes that existed of ARPANET in the United States. We're in the exact same situation now, but we're talking about now connecting quantum computers with quantum channels. And Qunnect wants to build the infrastructure which is going to support that. So what you may not realize is that you're actually standing in a building where we're transmitting entangled photons through Brooklyn and Queens. So what you're looking at on this map is all of the fiber which Qunnect uses as a network called Gotham Q, named after, of course, Gotham. And what we're going to show you tonight on the lab tours is that we're actually broadcasting in that loop that you see on the right that runs through Brooklyn and Queens, entangled photons through the streets of New York and collecting them and showing that they're still entangled. So you can think of it like the currency that you would use on a network. We also have other nodes in the network. NYU is one of them, our industry partner. And importantly, a very recent node that we're proud of is 60 Hudson Street, which is this huge co-location center in the old Western Union building in Tribeca. It actually is a place full of data centers, and Qunnect has a relationship with the data center QTD, where we're also going to be hosting some of our equipment there to be able to run quantum protocols. Okay, there we go. So what we've been doing for the past 4 years is building those pink boxes. And what they basically do are these very generic functions. One of them is to generate entanglement. So that's generating those special photons which are entangled, which are going to be sent into the fiber. But the fiber is going to corrupt them. Fibers are in the ground, they're aerial, they're in all of these places where environmental factors end up corrupting the information itself. So we've invented some tools to help preserve the identity of that entangled photon. So you'll see those on the lab tour. And then finally, something that validates it on the other side. So this is like a sort of decoding device so that you can tell that the information you sent was preserved in the fiber. This rack system is the first of its kind in the world. We are selling it right now to industry, government, and academia who are building the test beds, which are building the first protocols to run on the internet. We take it for granted when we use the internet today that these things just automatically find IP addresses and do things. But those protocols were invented. They were invented, many of them in the 80s. We are at the same stage now of empowering network engineers and the researchers who are building things like at Cisco to be able to build those protocols for quantum. So we have a lot of firsts as a company. We've been working very hard to do things the right way. And this is just a subset of all of these things, but we in 2021 actually released the world's first room temperature quantum memory. And oftentimes when you see quantum advertised in the news, you also see a really large freezer or a lot of smoke around these things because that's what you see for quantum computing. We actually can do everything that we do at room temperature. And in fact, we're starting to expand the capability of these things because the memories themselves add timing to the network. We also have the only entanglement source on the market, which produces those special types of entangled photons that make photons which are natively compatible with things like quantum sensors, quantum computers, and quantum memories. We also have some very special features on the entanglement source. The way we make those photons is that they're really identical. And you need those things in order to perform all the transactions that you actually want to do with quantum protocols. And we're really uniquely set up to do that. We also are the only company to build all of those other tools, like the network maintenance tools that allow networks to actually run. So it's not a science experiment. It's something that can actually stay on for 2 weeks or more. And we've demonstrated this on the network that we showed in the previous slide, running for more than 2 weeks at a time with extraordinarily high fidelity and a very low error rate. So this commercial turnkey system, the rack which is there, again, first of its kind, is now being sold. We've sold 3 of them so far. We have orders for more this year. And we're actually making these, right? We're making them here in the Brooklyn Navy Yard, and you'll see our manufacturing facility later. So the founders of the company will be helping to give the tours tonight. So Mehdi and Maël were graduate students when they first founded this company. I met them when I was working with Accelerate New York, one of the economic development establishments that were helping to fund companies that had very good deep tech or biotech opportunities. We've been together since 2020. We started off as 3 people, and now we're 21, which is very exciting. You might recognize the skyline in the background here. That's a picture of our team on the roof. And something we love to say is that we build hardware, not hype. So we're very proud of the fact that we're doing it. It's real. We're selling real devices. And the future is very bright for what we're going to do next. Thank you. I forgot to give the tour instructions. So we are giving tours. Our facility is 2 floors below. So what we're going to do is anybody who's interested in a tour, we're going to run them basically every 15 minutes. If you would please assemble outside the door to go on a tour at those 15 minutes, and we'll have someone to take you down to the facility. If there's more than 20 people standing out there, one of us will stay behind and the other person will take people downstairs. But we're just going to keep cycling. So if you'd like to stay for some of my colleagues' talks, please do. And then when you're ready to take a tour, just go out to the side there, just outside the entryway, and we'll show you down to the laboratory. Thank you.